Hello! Today we are going to discuss 3.5 using properties of parallel lines. Last class we talked about how we can prove lines are parallel if we know corresponding angles are congruent, if we know alternate interior angles are congruent, if we know consecutive angles are supplementary, or if we have alternate exterior angles are congruent. So today what we're going to do is we're just going to continue using what we've learned so far and apply those to other proofs that we might come across. This first one is called theorem number 1. And basically all it says is if two lines are parallel to the same line, then they are parallel to each other. So if you want, go ahead and write this information down, and you can pause the video and then come back and I'll explain how this works. All right, hopefully you have everything written down, and I want to just briefly explain this to you real quick. Of course, you're given that M is parallel to N and K is parallel to N. And we're going to try to prove that M is parallel to K. Now I know that that seems obvious, but if M is parallel to N and K is parallel to N, should we or could we really be able to say that these two are parallel? So we start out with the given information, and from that we know that angle 1 and angle 2 are congruent because they're corresponding angles. And we know that 2 and 3 are congruent because they're corresponding angles. Well, a little transitive action happens here, and then so you have 1 is equal to, or congruent to angle 3. So if you have 1 is congruent to 3, then you have transitive again for line M and line K. If you look at the picture and look where 1 is and look where 3 is, then you can tell that you have corresponding angles congruent. And so from there we'd say that since corresponding angles are congruent, then the lines are parallel, and that's the corresponding angles converse. Alright, so next what we're going to do is basically called theorem number 2. What you're going to do is we're going to read through this proof. If you want, you can pause the video and you can copy this down and then start the video again and I'll explain it. So I'll let you pause the video now. Alright, this is theorem number 2. It says, in a plane, if two lines are perpendicular to the same line, then the lines are parallel to each other. So we're basically going to prove that M is parallel to N, knowing that these two angles are perpendicular. Or I'm sorry, these two lines are perpendicular. So we start the proof off with our two lines, our two pairs of lines being perpendicular to each other. That's given. Now since we have perpendicular lines, we know that angle 1 and angle 2 are right angles. Of course, that's the definition of perpendicular lines. If they're both right angles, then they are congruent to each other by the handy-dandy right angle congruence theorem. And so then we've got angle 1 and angle 2, and if you look right over here, those two angles are corresponding angles. If they are congruent, then the lines are parallel, thanks to the corresponding angles converse. Alright, that is it for this video. All I want you to do now is to close the video and begin working on your assignment. Hope this helps.